Today we're going to cover how to find the horizontal asymptote of a rational function. So, in order to be able to find the horizontal asymptote of this, let's go ahead and get a look at our definitions over here on page 3. For horizontal asymptote, it is defined as a line that a graph approaches as the x values approach positive or negative infinity. What this will look like is a horizontal dashed line where the function starts approaching as it goes towards infinity. So I always relate this to a dog running along a fence. Gets closer and closer but never quite gets there. However, unlike with vertical asymptotes, it has been known to cross over once in a while, but only in some cases. So when it comes to actually finding them, we have to know a few pieces of information. There are going to be 3 cases for finding the horizontal asymptote, and those 3 cases are based on degrees. Based on degrees and leading coefficients. Based on the degrees and the leading coefficients. Luckily for us, though, we have already written this information down. So, in order to keep me from having to write very long sentences, I'm going to use symbols. When I talk about the degree of the numerator, I'm going to refer to it as d sub n and d sub d. This right here is the degree of the numerator. And this one right here is the degree of the denominator. The leading coefficients I'm going to know as LC sub n and LC sub d. The leading coefficient of the numerator, the leading coefficient of the denominator. It's important to distinguish between them. Now, there are 3 cases where I compare the degrees. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote has the equation y equals 0. I'm going to put a box around that so that way we can find it easily. The second case, if the degree of the numerator is equal to the degree of the denominator, the equation for the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator is equal to y. Finally, the third case, I'm going to write it over here. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So all we have to do is look at the information and determine the equation for our horizontal asymptotes, assuming that the function even has one. So let's go over here to our first example problem on page 4. And let's look at the degrees. Look at the degree of the numerator. What is the degree of the numerator? 2. What is the degree of the denominator? 2. Is the degree of the numerator less than, equal to, or greater than the degree of the denominator? They're equal. So let's look at that case real quick. The degree of the numerator is equal to the degree of the denominator, so the equation is y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. What that means for us is y equals, what is the leading coefficient of my numerator? 2 divided by the leading coefficient of the denominator, which is 3. So y equals 2/3. And so now, to plot this, I'm going to go ahead and look for 2/3 on the y and draw a horizontal line. Dashed. On the next example, it's the same deal. Let's look at the degree of the numerator. What is It is 1. What is the degree of the denominator? Which case do we have here? Is the degree of the numerator less than, equal to, or greater than the denominator? It is less than. The degree of the numerator is less than the degree of the denominator, so the horizontal asymptote has the equation y equals 0. So here it's y equals 0. Therefore, on my coordinate plane, I'm going to put a horizontal dashed line on 0, which is my x-axis. And that is how you find the horizontal asymptotes of rational functions.